we have here an example of a translational mechanical system. So for this problem, we have to determine the transfer function of the system. And here are the three important steps that we need to remember. First, we need to identify if a system is translational or mechanical, so we can use the correct formula for those. Then, we have to draw the free body diagram and write the force equations. Once we have those two, we can then solve for the transfer function. So first and foremost, what type of system is this? So if you can see here, we have mass. So this means this is translational system. Okay, so translational. That means we need to use the formula for M, B, and K for translational. Okay. And then next, we have to draw the free body diagram. So we have the FBD. Free body diagram. So the important thing about free body diagrams is that there is one corresponding free body diagram for every mass or for every inertia. So since we have M1 and M2, it's expected that we'll have two free body diagrams. So how do we draw free body diagrams? So let's draw first the mass M1. So we separate those two masses. And then we will have to draw all the forces connected to that mass. So for this one, we have, for mass 1, we have the applied force F of T. And then we have here FK1. So opposing force yan. So kabila yung direction niya to the right, to the left. So FK1. And then we have FB. And then we have FK2. Okay. And then don't forget that this box or this mass also has an opposing force from itself. So we have to indicate FM1 here. Okay, so that's for the first free body diagram. And then we have to indicate as well the displacement connected to it. So for this one, for M1, we have this Y1. So that's it for the first mass. Then another free body diagram is required for M2. So for M2, we have to look at again the forces connected to it. So for M2, what's connected to it is FK2. FK2. And then the force from the mass itself, FM2. So if you'll notice, we didn't indicate here any external force kasi wala namang connected sa kanya. So as a hint, what I do so that I won't forget this FM1 and FM2 is I draw a dot here as well, so I can include that. So to check, I count all the dots connected or that's within the box, and I count these forces here in the free body diagram. So it's very important that you get the correct free body diagram because that will be the basis in getting the force equation. So if you miss one of these forces, then mali na agad yung makukuha mong force equations, and in turn mali na rin yung makukuha mong transfer function. So this is very important and very critical as well. So we forgot to draw here Y2. Okay. So if I check your quizzes and if you miss this, so that will be minus points for the free body diagram. And then next we have to get the force equations. So for the force equations, we will base it from the free body diagram. So since we have two free body diagrams, then we will have two force equations as well. So before we get the actual equation, let's first get the corresponding formula for these specific forces. So paano kukuhanin yon? So yung mga formula na pinag-aralan natin sa translational and rotational mechanical system. So for equation 1, we will have Fm1 is equal to m1 d squared y1 over dt squared. So this is from the formula F is equal to Fm is equal to m dx over d squared x over dt, because remember, a mass is a function of acceleration. Okay, then we also have here, so check na to, we have FB is equal to b dy1 over dt. So I'm using y1 here dahil yun yung displacement na connected sa M1. And then what else? Fk1 is equal to k1 y1. So this one is from the formula F is equal to k not theta, sorry, kx. So since in this case our x is actually y1, so the formula is k1 y1. Next, we also have fk2. It's equal to, so for fk2, this is fk2, right? So it's connected to m1 and m2. That means this is case 2 for spring. So we will have to use the formula F is equal to Fk is equal to K theta, not theta, sorry, x1 minus x2. So this will be the formula for Fk2. So Fk2 is equal to K2 y1 minus y2. What else are we missing? Ft. So we will not get the formula for Ft dahil wala naman yung formula. It's an applied force. Okay. So now we have the individual forces. We can now get the force equation for mass 1. So F of T is equal to, so this is the applied force. And sabi sa Newton's law, if a force is applied, then there will be an equivalent opposing force. So Ft should be equal to all the forces here. So Ft is equal to Fm1 m1 d2 y1 over dt squared plus Fb b dy1 over dt. So you can actually first write this as F of t is equal to Fm1 plus Fb plus Fk1 plus Fk2. But I directly substituted the individual forces in this equation. But either way, that's correct. So Fk1 is k1 y1 plus Fk2 is k2 y1 minus y2. So now this is the ODE, and this is still in time domain. So dito na natin magagamit yung Laplace transform. So we need to take the Laplace transform of both sides. So we need it in S domain. So paano yun? So we will base that from this equation. This one. So, yung Ft magiging F of S is equal to M1 S squared Y 1 of S. Okay na to. Plus, yung B y1 of s, bs plus k1 y1 of s plus k2 y1 of s minus y2 of s. So this is the Laplace transform of the first equation. And we can further simplify this as ilalabas lang natin yung y1s from all the terms. So magiging m1s squared plus bs plus k1 plus, so ito i-distribute muna natin yung k2 before natin paghiwalayin. So plus k2, matitira to with k2. So hindi siya kasama sa loob ng y1s. Magiging minus k2 y2 of s. So ito na yung Laplace transform of the first equation. So second equation naman tayo. So just to make it easier, let's copy the diagram. So equation number 2. So katulad ng ginawa natin, let's first get the equivalent of the individual forces. So we only have two forces here. Fk2 is equal to K2. Since this K2, this spring number 2 is connected to both M1 and M2, kailangan natin gamitin yung case 2 formula, which is y2 minus y1. And then for Fm2, M2 d squared y2 over dt squared. So, since wala tayong external force dito, yung force na dapat external force will be equivalent to 0. So, in writing the equation, we will write it as 0 is equal to Fk2 plus Fm2. So, if we substitute, 0 is equal to K2 y2 minus y1 plus M2 d squared y2 over dt squared. So if we